So let's go back to our data. Please go back to your data on Smart PLS. We want to create a group.
Okay.
No, don't save. I hope I have my initial model. Yeah, I have my initial model. Good. Okay. Please, if you have this model, please open it. Or you can quickly construct it. Just drag the 3 variables and just put it there. It's easy to, now you should be very fast with that. But of course, the final model has no this. That is the importance of exporting your work, because you keep touching your model that you will lose some of the things you have in it. Okay, so we are here. I want to save this, then go back. Open your data, the training data. Open the data from the left-hand pane. When you open the data, we want to do something. We want to see if males and females are consistent in their evaluation of the model. So you go to create group. The top here, you can see back, setup, add group, generate groups. You click on generate groups. Please, are we all there?
Not yet.
So when you click on generate groups, you see all your variables listed. The first thing is go back to the raw data. Open the data, then this will open up. You click on generate group, then this will open up. Now select gender. When you select gender, click apply. Mine is already showing this because I think I created the group previously. So let me delete and do it again. Okay. Try this. So when you selected gender and apply, you should have something like this, group 1, group 2. Are you all there?
Yes.
Yes, we are there.
Now, if you're there, click edit. Click on edit.
Okay.
To open a new pop-up link. Group name. I want to call the group 1 male. Male. Then you apply. Then you go back to group 2, edit. I'll name it to a female. Then I apply. After that, I just have to go back. Go back. After doing that, you go back. When you go back, it takes you back to where you can select your model and the training data pane. Are we all there?
Yeah. Yes, please.
Now, the next thing we want to do is now select your model, which is the customer loyalty model. It should give you something like this. If you have it or whatever you've designed, it's just a demonstration.
Yes.
If you're here,
Yes.
you want to do calculations. Go to calculate.
Okay.
Now, what we are going to do now is that we are going to choose permutation multi-group analysis. Permutation multi-group analysis.
Yes.
So select permutation multi-group analysis. When you select, it will give you an option to please choose group A. We want our group A to be what? Males. and group B should be what? Female.
Hmm.
Can leave your permutations at 1000, it's okay. And the rest can just be left on default. So after that, calculate. You have a result. Interpretation of the
Yes.
result is key. Now I don't want to go back
Yeah.
to the slides for the lack of time. So I'm just explain the result. Now the first thing you take a look at when you have your output is to go to the part labeled MyCom. Your final result, quality criteria, MyCom. Can you all see MyCom?
Yes.
On the left-hand portal, final result, quality criteria, MyCom algorithm, MyCom here. When you click on the MyCom output, you see step 2, step 3A, and step 3B. Now, step
Yes.
2 is comparing the original correlations with the permutations correlations. That's the means. Now, okay, let me just give you the criteria. Now, the criteria here is that we expect the permutation p-values to be greater than 0.05. The condition for this, remember, when we are testing for hypothesis, we expect p-value to be less, right? But please get the conditions. In this test, we expect the permutation p-values to be what? Greater than 0.05. And the most important consideration could also be you compare the correlation here, 0 to the ones here. You can see that all the columns here, everything is what? Greater than what? 0.05. Now, that's just one consideration. But there are some instances you have red. That means you're going to have a partial invariance. But luckily, our data is perfect. So now the next thing you look at is you look at the step 3A. In the step 3A, we also require our p-values to be non-significant. That means they should all be greater than 0.05. That's I'm just giving you the requirement so that you just know how to make the decisions.
Again, please.
After that, you look at the step 3B, the variance, equality of variance. This is equality of mean. This 3A is equality of means, equality of variance. The same outcome. So everything is consistent. Now, the final interpretation of this outcome is on the final result. So when you've satisfied all these conditions, you go back to the path coefficient. That's under graphical final result path coefficient here. This is your statistical test. This is your final decision-making table. Here, I'm going to try and make it big so that we can see. I want to spend time to explain this better. So when you consider the other ones, you see males. When it comes to competency and customer loyalty, this is the difference in the ratings. This is the permutation difference. And you can see there is no statistical significance in the ratings by males and females when it comes to the effect of competency on customer loyalty. So it means they were all measuring the same thing. The construct was measuring the same thing. The same thing here. And the same thing here. So the results are not significant. So the different, we can see the differences are actually negligible. They are not so significant. So that's how you, but there are some instances you have mixed. So you can say partial invariance. So in this place, you don't have, we have no invariance in the data set. Any question? Have you all done that?
Yeah, I have a question, Doctor.
This was your question.
What is the importance of doing the measurement invariance and the multi-group analysis? What is the objective, the importance of doing this when we do our research?
Okay. Imagine when you design your questionnaires, why do you include the socio-demographic characteristics in the questionnaire? If you can answer that, then maybe we can both agree on something. Why do you add socio-demographic characteristics like age, locality, gender? Why do we add them?
Yeah, we add them because maybe if there is any relationship or significant difference between the male and the female, and between the male response on the dependent variable, on the independent variable, and the female response on the dependent and independent variable. So to check the relationship and the significance between the male and the female response, I think we include the,
Okay.
yeah.
So now with the answer you've given, can you see my screen?
Yes, yes.
So the measurement invariance. Can you relate what you've said now to the definition of measurement invariance? So as you rightly said, sometimes we want to see differences. So if I've administered my questionnaire on a group of people, I want to see if their responses are consistent across different groups. Are the males and the females, are they agreeing on the same thing, or is there a difference in their responses to the item?
Okay.
So it's the same thing we are doing.
Yes.
Do you get it? Yeah.
Yes, yes, yes.
Yeah.
Yes.
So we are just the measurement invariance for us to see if the specified groups are consistent in measuring the construct, or there's a difference between their responses.
Oh, great. Great. Thank you. Thank you.
Yeah. Hello, Doc.
Poco.
Yeah.
Okay.
Just a leading question. So if I have, let's say, a data set which has treatment variables, okay, like one section were exposed to a certain treatment and the other weren't, am I able to use measurement invariance to see if the effect varies across the different groups?
Obviously, if you have a treatment, it means you're applying treatment to one group and you've not applied it to the other group. So there's no basis to compare two of them. What do you think?
Yeah, so from the point whereby you do the measurement invariance, for instance, on customer loyalty, we realize that when it comes to likability on loyalty and all those things, we find out that there's no significant difference between how the males and then the females affect loyalty and all those things. Okay, so assuming that we want to say that males are more likely, so in that case, are we okay to still use measurement invariance or multi-group analysis?
The multi-group analysis and measurement invariance, they go hand in hand, you know? You can see we only perform one analysis.
Yeah.
First of all, your measurement, the respondent must be consistent in answering the questions before you can even check if there's a difference in the groupings. What I mean by that is, first of all, you check the measurement invariance first, because you want to establish that the specified groups are interpreting the indicators in the same way. So if they are interpreting it in the same way, then there is a basis for you now to determine, okay, if we've all gone through the same exam, then there's a difference for them to test us. If we've gone through the same lecture, then we can be tested on the same exam. That is when you now proceed to the multi-group portion of the table.
Good.
I don't know if you get the logic.
Yes, I do.
Any other question?
Hello,
Yeah, hello?
can I just elaborate my opinion?
Sorry, I didn't hear you.
Uh,
Can you speak a bit louder?
I mean that can I elaborate this question
Yes,
to my
elaborate.
understanding? Yeah.
Yes, elaborate.
If, for example, a gender is very important indicator in our analysis, so then we have to check for the multi-group analysis. If the multi-group
If what?
analysis, we have to check for the gender as we check now.
It
So-
is not, it depends on the framework of your analysis.
Exactly. So this, if we now we checked that the gender have no significant role, so it means that
Yeah.
we can run with this analysis. If the gender was significant, then we have to run this model for male separate and female separate. This is, I think.
You know, okay. The objective of what I'm doing is
Because
please-
one gender is affecting the responses of another gender. So then we have to separately elaborate. We have to divide the data into two groups then, and then we have to check the customer loyalty and with satisfaction, etc. But if the gender has no role, then this analysis is sufficient and we should go through and combine both of the samples.
Of course, you're right.
What do you think?
Yeah, that's what the result is telling us, that
Yeah.
they're all saying the same thing.
Exactly.
So the sample is consistent.
So
Yeah.
exactly. So in this analysis, we can have no role of the gender. So means that we don't need to repeat this model again and again for two groups.
Yeah, it means there is no gender difference in the
Exactly,
model. So yeah,
exactly,
so we can
exactly.
combine the data and continue with the
Exactly.
analysis.
We can combine the data. No stratification is needed.
Exactly. You're right. Any other question?
Yes, doctor, can I ask one question, please?
Okay.
Just going back to the structural and the measurement model.
That's very
Do
far
we-
back, my brother. I think I'll appreciate questions on what we covered today. Then probably, yeah. I think it will be taking us like almost 2 days back.
Yeah.
Yeah,
Sorry.
so
So
maybe maybe you can contact Dr. Kwame or you can contact
Okay.
me.
Okay.
Yeah.
Thank you.
You're welcome. So I think this will be the end of the training program, and I do want to add that what we've covered so far can be considered to be introduction to structural equation modeling. We've only covered the partial least square model. We didn't even touch the CB model. So there are other complex models we can build, like multi-group models and so on and so forth. So, but for the non-technical user, I think this should be okay. But for those who want to do advanced analysis and structural equation modeling, you will do well to build on your techniques. So thank you all for attending, and over to Dr. Kwame.
Hello, Doc.
Hello, everyone. Once again, thank you for having you here, and it's a pleasure. Thank you, Dr. Phil. I think we have some 10 minutes more, so I'm not sure how best we want to use it. But what I can say is we appreciate you letting us have you here. And for you, the people who attended the program, we appreciate you giving us a nice environment to learn. We'll be uploading the video to the YouTube channel. I have shared the link. You will have access to the data on the YouTube channel any day, anytime you want to go back to it. Feel free to check. With any other thing you want, you can also let us know. I'll be happy to make short videos on some data analysis and other few things we also know and post them on the channel. So if you want to get those notifications, feel free to just subscribe so that when we share the training, you can always get the notification and then watch them. We'll be making these short videos, 5 minutes videos, 10 minutes videos, explaining some of these analysis and other statistical softwares on the channel. So once again, thank you for having you here. And I would like all of us to say a big thank you to Dr. Phil for gracing us. So let's all say a big thank you to him for the session.
Thank you.
Thank
Thank you,
you.
Dr.
Thank
Phil.
you, Doc. Thank you
So much.
Thank you,
Thank you
Dr.
so much, Doctor.
Thank you very much,
Thank you
Doctor.
all.
Very
Thank
much,
you all for the
Dr.
privilege
and Kwame.
to share with you.
Yeah.
Thank you.
Thank you very much,
Thank you
Doctor.
for your
Thank you so much. We
impact
appreciate
knowledge.
really your hard work.
Doc, we
Okay,
really,
thank you,
really
everyone.
appreciate.
Please feel free to check the channel in an hour or two for the videos. And as I said, feel free to subscribe so that you always have access to the short explanatory videos we'll be posting on the channel. Okay, so have a good day. Until then, we see you in another training. Bye.
Wow. Thank you. Thank you. Thank you so much,
Yes,
Doctor.
thank you very much.
Dr. Phil, Charlie,
Bye.
thank you so much.
Thank you all. Thank you, Dr. Kwame, for being the able organizer and coordinating everything. Thank you as well.
Okay. Bye.
Doctor, can you give me